All right, so more quadratics. So yesterday in class world, which was Friday, we learned how to solve quadratics by factoring and completing the square, right? Okay, so if you're going to, so your first method of choice should be to factor. If you can factor, do that. So when you're factoring, what do you have to do with the equation? Set it equal to 0. So what would you move over in this one? The 10. So you'd make this into x squared minus 3x minus 10 equals 0. And this is one of the easy ones. You think, are there things that multiply to negative 10 that add to negative 3?
Negative 5 and 2.
X minus 5, x plus 2. And then you say, well, x minus 5 equals 0, or x plus 2 equals 0, which you can totally do in your head if you're that fast. What do you get for your answers then?
X equals 5, x equals negative 2.
Yep, 5 and negative 2. And that's kind of the most common thing that's going to happen in calculus is lots of this, like tons of factoring. You got to know, you see x squared, you factor. I made my Algebra 2 students do it here, and of course I said, I say solve, you say factor, and they're like, oh, shut up, you're so strange. Okay, this one, I'm going to do something that's not technically wrong, but makes the factor pattern break. If you do this, you can't factor yet. Because the factor pattern that you know depends on it being a positive 1x squared. Does that make sense?
Couldn't you just move the 11 as well?
Yeah, so what you could have done is moved the 11 over to the other side and also the 10. Does that make sense?
What if you factor out negative 1?
You could, but yes, so there's lots of ways to do this right. So if you see, if you like this better, what you could do is divide both sides of the equation by negative 1 or factor out a negative 1. Those are both okay, and you're going to end up with the same exact thing. My point is if you end up with a negative x squared, get rid of it somehow. Does that make sense? Okay. So now, and look, they're both the exact same equation, aren't they? Okay, so how does x squared plus 10, 11x plus 10 factor? X plus 1 and x plus 10. And so one answer is given by solving x plus 1 equals 0, the other one x plus 10 equals 0. So what are the two answers?
Negative 1 and negative 10.
Yep, very good. Okay. What's next? All right, same idea, right? Do you want to put the 7x on the left or put the 3x squared on the right?
7x on the left.
7x on the left. Okay, so 3x squared, will it be minus 7x or plus 7x?
Minus.
Don't fall asleep, Tristan. Okay? All right, Tristan, what do we do next? You answer questions, stay awake.
Factor out the x.
Okay, great. And you get x parenthesis
3x minus 7.
3x minus 7. So everyone understand what Tristan did there? Okay. How can you tell that you're going to have a greatest common factor? What's missing? The constant term. Yep, exactly. Okay, and so one answer will be x equals 0. And the other one you find by solving 3x minus 7 equals 0, right?
2 and 1/3.
Yep. Probably better to give it a 7/3 though.
Okay.
Does that make sense? I know that that's not what you were taught in elementary school. But the reason that it's better is actually a pretty good one. So my web assign students in calculus, if they give their answer as 2 and 1/3, they're actually marked wrong. And the reason is because this notation is ambiguous. It's not clear if you mean 2 times 1/3 or 2 plus 1/3. Do you see that that's a little bit weird? Which one does it actually mean?
The 2 plus 1/3.
The 2 plus 1/3, right?
Doesn't really make sense
Because in math, whenever you write something like that, it means times, right?
Yeah.
So yeah, that's the reason like that WebAssign won't take it. And actually, multiplying, dividing, adding, subtracting fractions are all easier when they're in that form. So there's almost no, I don't know why elementary school focuses so much on mixed numbers, but it's probably to get relative size. To say, oh, 7/3 is a little bit bigger than 2. So that, does that make sense? That's probably, I think that's why they do that so much. But from now on, for the rest of your mathematical life, you can give me improper fractions as long as they're reduced. Okay, this one. So keeping with the whole positive x squared thing, let's move the 6 and the 13x to the left side. So that becomes 5x squared plus or minus 13x. Plus 13x. Very good. And just because I'm faster this way as well, let's do that like grouping way. So what's your magic number? They multiply to negative 30, and they must add to 13. Okay, so if they're gonna,
Negative 10 and
okay, so why is negative 10 and negative 3? Why is that wrong? It's a,
multiply them, they don't know.
they multiply to positive 30, right? Okay. Negative 15 and 2 is awfully close, but you corrected yourself. Yep. 15 and negative 2. Does that make sense? Okay, and that breaks into 5x squared plus 15x minus 2x minus 6. Come grab a packet, Tani, even though you're late, it's okay. And some people call it the walk of shame, but it's okay. Well, I'll stare at you. Okay, take out the greatest common factor from each group. So what's the greatest common factor in that first group? 5x. Yeah, you're in the next group. So 5x times x plus 3. How about the next group? Negative 2, very good. Negative 2, x plus 3. That's your final answer is, well, semi-final answer is x plus 3. Does it matter what order those get written in? No.
I like to put the 5x first, though.
Okay, well, if you like that better, that's totally fine. Do whatever you want.
Why did you need to write out that part? The plus 15 and the minus 2x?
So that's just
So
grouping.
that is a technique called grouping that allows you to factor polynomials like this. What did you want to do instead?
I just went straight to 5x minus 2x plus 3.
As in you just guess and checked it. That's also totally fine. Some of us suck at guess and checking. Me. Okay, not you. So if there's two methods, right? And so if you got straight to 5x minus 2x plus 3, that's totally fine.
Personally, I guess and check on any prime x squared.
Yeah,
But if
no.
it's- But if it's it's non-prime, then I won't.
It's good to have a strategy. X equals negative 3. What's the other one? Add 2, divide 5, 2/5. So just because it is good to know how to do it, and because a lot of calc teachers might do it that way, if you have to guess and check, you say, I have 5x squared, that has to be 5x and x, right? There's no other options for 5x squared. Does that make sense? And then for making the negative 6, you either could have had, like, you could have had a 3 there and a 2 there, you know, one positive, one negative. You could have had something like this. And you just multiply them together to see which one's right. Are either of those right?
Wait, I think of it is what factor of 6 multiplied by 5 equals the other factor.
Factor of 6 multiplied by 5 equals... I'm afraid my brain can't process that this morning.
Okay.
Talk to me about me think about it, okay, before I try to explain to people I don't fully understand what you're doing, okay? But technically speaking, are either of those correct, the ones that I've written down? The second one is closer, isn't it? And how you'd be able to tell is you would get plus 2x, and then you're going to get minus 15x, which makes negative 13. It's awfully close to positive 13, right? And once you get the opposite sign for your middle term, you just flip-flop these signs, as in put the minus with the 2 and put the plus with the 3. So, if you can guess and check, that's the faster way. All right, now we had some problems that were missing constant terms. We also have some problems that are missing linear terms, as in the thing that has an x. If you're missing the quadratic term, you're not a quadratic equation anymore, you're a linear equation, so we don't do any of those. So if you're missing the linear term, you can solve using square roots. So you got to get the x squared as by itself as you can, and then use a square root. So what would you do first here?
Subtract 1.
Subtract 1. Great. 5x squared equals 50.
Divide by 5.
Mm-hmm. X squared equals 10. And if square root, is square root 10 the only answer?
No, plus or
No.
minus.
Plus or minus, very good. That is the one danger with square roots, is you could forget the plus minuses. Okay. How about this one? How would you start?
Divide by 3.
Yeah, does everyone see that 3 out in front? So you'd get x minus 4, because x plus 4, sorry, squared equals 7. Okay, great. Now square root both sides. What does square rooting do to the squared?
Just away.
Bye-bye. X plus 4 equals plus or minus root 7.
Subtract 4.
Mm-hmm. So negative 4 plus or minus root 7. And that-
Technically,
mhm.
since there's a plus or minus, couldn't you just put 4 plus or minus, because you'd get the same thing?
Couldn't you put,
Because
so you want me to put 4 plus
Yeah,
or
it says
minus?
4. Wouldn't that be
One
the same
big X
thing?
and goes.
So you want this to be the answer?
Yeah, could that be because of the plus or minus, or no?
No, it couldn't, because the plus or minus is multiplied by the root 7.
Okay.
And it's because you have to move 4 over to that side, you take it away.
Okay.
So technically, what I've just, this actually could be plus or minus root 7 minus 4, which is the same thing as that.
Okay.
And it's just often the case that the plus or minus is written in, like, that's the second number, but it's not necessarily wrong either way. But yeah, this will give two completely different answers. Okay, so now we're gonna review how to complete the square. So this is a technique that you can use when factoring fails. We're gonna learn another technique today called the quadratic formula, which you probably have all heard about. So when you complete the square, the pattern is you add half of, in this case, what number would it be? 8 squared. But before you do that, what do you move away?
subtract 6.
Subtract 6, very good. X squared plus 8x equals minus 6.
16.
Add 16 to the left, and because math is fair, you also
Add to the right.
add to the right. And that gives you, now the reason you hold do that thing is that this thing now factors into x plus what squared?
4x. I mean, just 4.
X plus 4. Does that make sense? 4 times 4 is 16, 4 plus 4 is 8. Equals 10. At that stage, doesn't it look a lot like the other one that we had? Yeah. So square root x plus 4 equals plus or minus square root 10. And x equals positive or negative 4? Negative 4, great. Has anybody gotten to stuff like that on Alex? Do they want roots or do they want decimals?
They want roots.
They want roots? Okay. If you were to do a decimal, you'd work out what root 10 was and do negative 4 plus that number and then negative 4 minus that number, right? Okay.
They might, typically if they say round to the nearest 10th or whatever.
If they want stuff like
Yeah.
that. Yeah, of course. All right, this one. Well, let's move the 6x over. 3x squared minus 6x equals negative 1. Can I do completing the square yet?
Now you have to divide by 3.
You have to divide by 3. So take that whole equation and divide everybody by 3. Kind of like our easy factor pattern only works for positive x squared. That easy complete the square pattern only works if you've got positive x squared. So x squared minus 2x equals negative 1/3. And I have to say that your textbook for this class is like a lot nicer about those problems, because does it make sense that when you divide by 3, the fact that that's negative 2, as in it's an even number, makes the completing the square easier? Because half of an even number is a whole number as opposed to a fraction. My Algebra 2 textbook was not so nice to my high school students. So what's half of negative 2?
Negative 1.
Tristan, stay awake. 1 squared is? 1. So add 1 to both sides. Okay. All right, now that factors into x minus 1 squared equals, so 1 is 3/3, right? What's negative 1/3 plus 3/3? 2/3. Okay, great. So square root both sides, x minus 1 equals plus or minus square root big fraction. Would I be right if I suspected that your Alex is also probably wanting rationalized denominators?
Actually, in this situation, you want to rationalize the numerator first and then the denominator so that you can subtract.
I don't think it's a big deal. I think you rationalize the I think you're wrong. You rationalize the denominator first.
I
So,
don't think Alex cares, so.
okay, I think they might care about rationalized denominators.
I don't know.
Yes.
Okay.
This is
So it's kind of also common, like, it's kind of like math grammar, like you're supposed to always reduce your fractions, you almost always rationalize your denominators, so let's just do it in case that's required. Is everyone okay with the fact that both the 2 and the 3 are rooted? Okay, and do you multiply by root 2 or by root 3? Root 3. And so that's 1 plus or minus root 6 over 3. And you can leave it like that. That's fine. Or you could also say 3 plus or minus root 6 all over 3. Do you get why that's the same? Okay, so either, I don't know if they want a specific form, they're both acceptable. I'm also, different teachers prefer different ones in terms of which one they want, so it's just good to be able to recognize they're the same thing. Yes. How did I get the next one?
No, well, the 3 plus minus 6.
Mhm.
The 3 on the top, how did you get that?
I took that one and multiplied it by 3 over 3. Does that make sense? So I was getting a common denominator. This one
Oh,
became this, right? So, and when you add the numerators, you get 3 plus or minus root 6 over 3. Yep. Okay, awesome. So now I purposely did one that's a little bit harder because we're going to do one that has only letters in it after this, which is going to be super fun. So solve this one by completing the square. What do you want to do first? Divide by 3. And even though this method is like really cool, it's also really tedious sometimes, and this is one of those like tedious sometimes examples. So if you divide by 3, we get x squared plus what?
5x over 2.
Somebody else? 5/3 x, great. Plus 1 over 3 equals 0. Great. Okay. So that's x squared plus 5/3 x equals negative 1/3. All right. So if you take 5/3 and you divide it by 2, what's half of 5/3? 5/6. Does that make sense? It's 5/3 times a half. It's 5/6. So you add 5/6 squared to this side, and you add 5/6 squared to that side. You can think about it for easy fractions. If you have a half, half of a half is a quarter, right? So, okay, so now how is that junk on the left going to factor?
25 over 36.
It becomes 25 over 36 when you multiply, but doesn't it just factor into x plus 5/6, the whole thing squared?
Yeah.
Because 5/6 times 5/6 is 5/6 squared. 5/6 plus 5/6 is 10/6, which is 5/3, right? That is the factor pattern. I know that's weird. On the right, you got to multiply it out. Negative 1/3 plus 25/36. I'm gonna erase this stuff. What would the common denominator be on the right side?
36.
So what do you multiply the first fraction by? 12, great. X plus 5, 6 squared equals negative 12 over 36 plus 25 over 36. We're almost done. X plus 5 over 6 squared equals, is that 1336? Okay. Anybody feeling like they're a little sick of this method?
I would use the quadratic formula.
Which is we're going to prove. X plus, we're going to actually show you why it's true, plus 5, 6 equals plus or minus root 13 over 6, right? Is that okay? And so then X equals negative 5, 6 plus or minus root 13 over 6. And some of you are saying what I'm thinking is completing the square kind of sucks for that problem, and you would use this thing called the quadratic formula, right? The whole negative b plus or minus square root b squared minus 4ac over 2a. Do you know how you prove that? Like how you establish where it comes from? You complete the square. Yeah, so what you do is you say, oh, the completing the square thing is all these like similar steps over and over and over, right? What if I just do them with a's, b's, and c's instead? So I'm going to actually do that with you because it's totally like this problem, okay? Yes?
Like, you can rewrite that problem as all over 6.
Yes, so tell me what you think it should be.
Negative 5 plus or minus root 13 over 6.
That's also perfect. Yep. Both are fine. So I think this is pretty exciting because it's good to know why stuff is true, not just like accepted on faith. So solve this by completing the square, and then I'll, what have you just done? I'll share my excitement. All right, so think about the last problem. How we start this one, we divide by a. Does that make sense? Okay. So that will give us x squared plus b over ax plus c over a equals 0. So far not hard, right? You just divided by a. Move the c over a onto the right. And it's negative c over a over there, right? Now the tricky thing is what to add in. So what was half of 5/3?
You just put a 2 at the bottom.
It was 5, 6, right? So what's half of b over a?
B over 2a.
B over 2a. So we're going to add in b over 2a, the whole thing squared. B over 2a, the whole thing squared. It's the exact same as the numbers we had in the last problem, right? Other than the fact that they're letters. Okay, now how does the left side factor? X plus b over 2a, the whole thing squared, equals negative c over a, plus when I square the b over 2a, what do I get?
B squared over 4a squared.
B squared over 4a squared. Do you guys agree with that? Okay. So now how about before I square root, I get a common denominator? Does that make sense? So what would you multiply the c over a by?
4a squared.
Just 4a. Okay, so that gives us x plus b over 2a, the whole thing squared, equals negative 4ac plus b squared all over 4a squared, right? Does that make sense so far? Okay, square root both sides. X plus b over 2a equals plus or minus big huge square root sign whole fraction. Is everyone okay with that? Does it look kind of familiar-ish? Yeah. So that's x plus, I'm gonna do two things. I'm going to flip-flop the order inside the square root sign. So put the b squared first and the negative 4ac second. Is that okay? When you square root the denominator, what does it become? 2a. And what's the final thing you do? What do you do with this b over 2a? Subtract it. Is that usually how they write it, though?
No.
They usually write it as one fraction, right? Negative b plus or minus the square root b squared minus 4ac all over 2a.
I don't understand why we learn the quadratic formula and then completing the square later. It seems to be better if we learn completing the square first.
That's because you learn the quadratic formula in Algebra 1, and students are incredibly immature in Algebra 1, and when you try to show them this, they like want to murder you as a teacher. So, I've tried, okay? Like, been there, done that. And it's because of where it shows up on assessments. It ends up being really bad because it's just like a formula and you're supposed to use it as opposed to understand where it comes from. So, it comes from completing square though. So now you guys know where it comes from, and you can use it. You just memorize, like it's something, one of those things in math you just have to know. So, if you ever forget it, completing the square is also an option, right? So, I used to think that when you can't factor that this method was always better and completing the square kind of sucked. But completing the square is actually really, really, really nice for certain things. Specifically, I think it's super nice for stuff like this.
Yeah, things where the second part is even.
And that is x squared. Does that make sense? So completing the square is super nice for stuff when you have singular x squared and this number right there is even. That's when completing the square is super awesome and actually faster, right? If your quadratics get more complicated and you can't factor them, then this is your fallback method. And the other thing is that this always works. So my goofy Russian husband calls factoring solving by staring because in Russia, when he was growing up, he just learned this thing because it always works, as opposed to sometimes works. So one of my classes that he called it solving by staring, and like the next day he went and subbed, and he's like, well, I guess we could solve by staring. I thought that was pretty hilarious. Okay, so solve this one using the quadratic formula. Now, one thing about that formula is the A, B, and C that you have, they are chosen based on the fact that your equation must be equal to 0 before you start. So this one, you have to move the 2 over. And then your A is the coefficient of the x squared. So A is 3. The B is, and the C is, okay. And so I'm gonna write the formula down. Negative b plus or minus the square root b squared minus 4ac over 2a. The best way to learn stuff, if you have to memorize it, is to write it down like a whole bunch of times. If you write that down for every problem that you do, you're gonna have it memorized whether or not you want to. You're gonna have kids someday to be like, I know that formula because Mrs. Irvis made me memorize it. Okay, so I'm gonna do some stuff quickly here because I think being fast is also a good skill. When you plug in -5, what happens to the double negative? Becomes a positive. When you plug the -5 in and square it, what does it become? 25. Will that b squared ever be negative?
No.
No, never, okay? And the next part, I can't do 3 things in my head at once. I'm just writing down -4 times 3 times -2. If you're faster than me, awesome. All over 2a, which will be 6. Great. So 5 plus or minus. If you mess up anywhere in this formula, the next step is where it's going to be. So this, you can think about this as being a negative sign and that as being a negative sign. So you multiply a negative, a positive, and a negative. What's the end result? A plus, a positive. So that becomes 25 plus, I think that's 24. Does that seem right? Okay. It's 49. Yeah, this one works out well. when you get one that works out well, as in it, under the root sign, you get something that is a perfect square and roots nicely, that means that your original problem could have factored. Does that make sense? Like, so it would have worked that way. So that's 5 plus or minus 7, right? Over 6. So one answer is 5 plus 7 over 6, which is 12 over 6, or 2. The other is 5 minus 7, which is negative 2. Don't give me negative 2, 6. Give me negative 1/3. Good job. That's just an exercise in using proper order of operations, isn't it? Yeah. Okay. So that one worked out nicely. The next one will also work out nicely. Let's skip part B because it also works out nicely. If you want to do it, great, but I think you can get it. All right, this one. Well, that's part B, so I'm going to skip that. Sorry, this one. Now, do you think it's easier to plug whole numbers or fractions into the quadratic formula? Whole numbers, right? So could you manipulate this expression so that you only have whole numbers?
Yes.
Yeah, how would you do that? Multiply by 2. So that gives us 4x plus 3 equals 2x squared. And I think just out of habit, I tend to move everything on with the x squared and keep the x squared positive. 2x squared minus 4x minus 3, although it will work the other way as well. See what I did there? Took away 4x, took away 3. Okay. So negative b plus or minus square root b squared minus 4ac all over 2a. Okay, so 4 plus or minus root of 16, right? Minus 4 times 2 times, yep, all over 4. Plus, okay, 4 times 2, 8. 8 times 3, 24. This one gonna work out nicely? No. 4 plus or minus root 4t. If it was a test question, it was like my Algebra 2 class, I'd give them like 5 out of 6 if they got to there.
That's because he didn't factor out.
Yeah, so do you know what I mean? Why would I give them 5 out of 6?
You can reduce the,
You can simplify the root 40, can't you? You can think about 40 as 40 is the same thing as 4 times 10, right? So that becomes 4 plus or minus root 10 is still there. What's outside of it? 2. I probably should have given them 4 out of 6 because there were 2 more steps. What's the other thing you can do to this? Reduce the fractions, divide both by 2. So that becomes 2 plus or minus root 10 over 2. Technically, how many answers is that? 1 or 2? 2. Okay. All right, how about this next one? Yeah.
Can't you just cancel the 2?
If you cancel the 2s, you could write this as 1 plus or minus root 10 over 2. That would be okay as well.
Oh,
But the thing is that big fraction bar means both pieces are divided by 2. Yep, so you can as long as you still leave the root 10 over a 2. Okay, I know that part B in example 8 factors, but I want to point out what happens when you do the quadratic formula on this, okay? So this is the same thing. If you're going to use the quadratic formula, you have to have it as an equation equals 0. So x squared plus 6x plus 9 equals 0. So holy bananas, stick a right in it, negative b plus or minus the square root. Okay. So that's negative 6 plus or minus the square root of 36 minus 4 times 1 times 9 all over 2. What number do you get inside that square root sign? 0. Okay, so -6 plus 0 is still -6, right? -6 minus 0 is still -6, right? How many answers do we get this time? Just 1. So the reason I did this, I want to talk about what part of this expression determines if you have 2 answers or just 1 answer. And then what part of it determines if your answers are real or imaginary. We didn't have any imaginary ones, but you would get imaginary ones if you had a negative in the square root sign, right? So that thing inside the square root sign, that b squared minus 4ac, that's called the discriminant. And it's because that part alone discriminates between what different kinds of solutions you could have. So if that discriminant is 0, you have 1 answer. Does that make sense? If that discriminant is positive, you're going to have 2 answers and they're real, right? What if it's negative?
You're gonna have imaginary.
And you're going to have 2 of them, right? Okay, so that's what some questions are going to ask you to do, is just tell me how many answers and what kind. Does it make sense that the 1 answer will always be real? Because the square root's always going to be 0, right? So no i's are going to happen there. That's what those next lines say. So which part determines if your solutions are going to be real or imaginary? That part is the b squared minus 4ac, and it's called the discriminant.
Would you have a square root over that?
Nope, because the thing is, you know that you're going to square root it. So if this thing is negative, you know you're going to have i's. If you want to put the square root there, you could, but the discriminant itself is just the stuff inside the root sign. So if it's positive, then you have 2 real answers. If I say they could be irrational, does that make sense?
Yep.
Like they could have square root of 10 in them, for example. That's irrational. What if it's 0? How many answers? 1 real. And then how about negative? 2 imaginaries. So when you're asked, like that's why there's like 0 space on example 9, because all I'm going to ask you to do is figure out how many answers and then what type, not actually find them. Okay. So all we're going to do is we're just going to work out the b squared minus 4ac bit, nothing else. So in this case, the b is -6, right? So what's -6 squared? 36 minus 4 times 3 times 5. So that's 36 minus
A much bigger number.
minus 60, a much bigger number, which is negative how much just for practice?
24.
Yep. So since this is negative, we have 2 imaginary answers. So if you were to work out the quadratic formula, you're going to end up squaring -24, which gives you 2 answers that have i's in them. You don't have to actually work it all the way. Okay, how about this next one? It'll be 36 minus 4 times 3 times 1, is that right? So that's 36 minus 12, right? Which is positive 24. So are there going to be real or imaginary answers you get? Real, and how many of them? 2. So 2 real. All right, this one. So we'll have 36 minus 4 times 3 times 3. I think that's 36 minus 36, which is 0. So 1 real answer. I think we had some equations that were fractions, didn't we, at some point in time? They just involve fractions where the fractions were numbers, right? Not often where the denominators. Well, I guess we had a couple that had denominators that were expressions, didn't we? Like over x minus 1. What is one thing that u cannot be in this equation?
0.
Yeah. So let's just write that down in case that is an answer that we get. We know we have to leave it out. So how about we start this problem? I don't know about you, but the first thing I would think is that if I see a fraction, I think common denominator, right? Does that make sense? And I think it's easiest to get a common denominator across the entire fraction. So what do you multiply the fraction on the left of the equal sign by? U. So that's going to be 2u over u squared equals 3 over u squared. And what does the 1 multiply by? U squared. So I multiplied this guy by u over u, this guy by u squared over u squared. And then at that step, because you can take this whole fraction and multiply by u squared, what happens to every single denominator? They're gone. So you have 2u equals 3 plus u squared. And that's kind of like the verbs and adjectives and stuff are out of order in a sentence, and it kind of bothers me. So I'm going to rewrite that as 0 equals u squared minus 2u plus 3. Does that make sense? Okay. I don't think that factors. Does that factor?
It does.
Oh, no, it doesn't. Multiplies to 3 and adds to negative 2.
Oh, wait.
Yeah, if it were negative
Yeah,
3,
for a second I thought it was negative.
if it was negative 3, then it would factor, right? So now, do you want to use the quadrant formula, or do you want to complete the square?
Complete the square.
Let's complete the square, right? Okay, so can I put the, tell me if this is going to confuse you. If I say u squared minus 2u equals negative 3, is that too confusing?
No.
Because you just moved the 3 over with the 0. I just wanted the u squared on the left. It just makes me feel better. Does that make sense? Okay. So what number do I add to both sides now? 1. So u minus 1 squared equals negative 2. When you root both sides, you get u minus 1.
So how can you know that you're supposed to, once it's equal to 0, that you're supposed to?
How do I know I'm supposed to complete the square? It's just a lot of intuition and practice. So I know it won't factor because nothing multiplies to 3 and adds to negative 2. And once you know something won't factor, your options are complete the square and quadratic formula. Does that make sense? And so I know that completing the square is easy if I have a 1 in front of my variable squared and this number is even. Does that make sense? So if you're not certain if completing the square is going to work out well, the quadratic formula always works. It just might take longer.
So then complete the square and then
Nope, completing the square is like reproving the quadratic formula. So you're either just gonna, when you get to this step that's circled in purple, your options are at that step, either you do QF or you complete the square. Okay, does that make those are your two options? You either do one or the other. And I chose complete the square because I have u squared and I have a 2u. And the fact that that's an even number makes completing the square easy.
okay, so we're just switching.
I'm trying to get you to understand like when you would choose one method over the other. Just because it works better, not only because like the quadratic formula always works. You could always use that and never use anything else if you wanted to. And so u will equal 1 plus or minus I root 2. the next one takes a little bit of space, so write small. I'm so sorry, okay? You okay with this one?
Could
Yeah.
you read it as -2 root -18?
You should take your eyes out. Does that make sense?
Yeah.
Yeah. So, I mean, all you can do is take out the I, so do that. I mean, if it was a test question, you might lose a point or half a point or something like that. Okay. Any other questions with that one? Natalie, do you have a question? Okay. So yeah, the next one is just ugly, but let's just start by, how about we factor that first denominator to see what's there, okay? So the first denominator factors into x plus 2, x minus 2, right? Do you see that's a little bit evil with the second denominator?
Yeah.
Because the second denominator isn't x minus 2, it's 2 minus x. So does everyone understand that I can make that into x minus 2 by taking out a -1?
So instead of the plus, you put a minus.
Yeah, so I'll just put a -1 there for now, but I'm going to do what Cole said in just a second. And I think I have an even better method than just putting a minus sign. Because how many of you in your past lives have forgotten to distribute a negative? Oh, come on. Everybody in this class has forgotten that, haven't they, at some point in time? So how about instead of making it a minus, why don't I multiply both things in the numerator by -1? Does that make sense? So that'll make this into 11 over x plus 2, x minus 2, plus -x minus 3 over x minus 2. Is everyone okay with that?
So you can just move the negative up to the top.
And what you're kind of doing there is you're saying, okay, well, I can just do the division part where I do x divided by -1 is -x, right? 3 divided by -1 is -3. Or, if you don't like that way, you can also think I'm just multiplying the numerator by -1 and the denominator by -1, right? That's also the same thing, isn't it? Because multiplying by -1 over -1 is all good, and multiplying this -1 and that -1 go away, right? And then this -1 makes both terms negative. There's lots of ways to think about that, but they're all correct. Okay, and now you can be a little bit frustrated about the common denominator because it kind of sucks a little bit. What do you multiply the first fraction by? Okay, second fraction?
X plus 2.
So don't forget parentheses around that stuff. X plus 2 over x plus 2. How about the one on the right?
X minus 2.
X minus 2. Okay. So can I just forget that the denominators ever existed at this point in time?
Yes.
Yes, because I could multiply by it and it'd go away, right? So 11 plus, multiply the two things there together. So what do you get? -x squared minus 2x minus 3x, which is -5x. Yep, you're right. And then minus 6, great, equals 2x squared minus 4x, great, minus, plus 6, good. And let's just combine like terms on either side. -x squared minus 5x, is that going to be plus 5? You guys agree with that? Equals 2x squared minus 7x plus 6. You know there was that game Words with Friends? You should do math homework with friends so you can like check steps. All right, let's move everything. I'm just going to put it all on the right side just because it doesn't really matter. So if I add the x squared over, how many x squareds do I have? 3. So then if I add the 5x over to -7, you get -2x. Take away the 5, I get plus 1. Okay, I know it's tedious at that stage. Your options are factoring. Does factoring work? You multiply 3 and 1 and you get 3, right? Does anything multiply to 3 and add to -2? No, so factoring fails. Do you want to complete the square? Probably not, because you're going to have fractions, right? So then your fallback option is the quadratic formula, right? So QF, so sorry. So you get x equals -b, so that's 2 plus or minus the square root of 4 minus 4, 3, -1, all over 6. +1. Yes, I was just testing you. Good job. Oh man, so I think that's 2 plus or minus, what number's in that square root sign? -8, that's what I got, yeah.
That's like the worst possible problem.
I know, I'm so sorry. So 2 plus or minus, can you reduce? Yeah, 2i root 2. Do you guys get how they got that? They thought about -8 as -4 times 2, right? All over 6. And yeah, Cole is definitely right. This is like the worst problem ever, because not only are the answers imaginary, they must be reduced. And I mean, it's just evil. So 1 plus or minus I root 2 over 3. I mean, it's like a quiz question, half a page, if I were ever to do that to you or myself. Okay. Whew. Which word problem do I want to do? Let's do example 11, and then we'll finish the rest of it. The lessons in chapter 2 that we're going to do this week are going to be really short, so we'll probably we'll finish this 1-5 next time. One word problem. So a casino boat takes 1.6 hours longer to go 36 miles up a river than to return. So if the current is 14 miles per hour, what is the speed of the boat in still water? So I don't know about you guys, but whenever I see times and things about like moving, I think, oh my God, distance equals rate times time. Does that make sense? Okay, so distance equals rate times time. I have to use that somehow. And I don't know how fast this boat is going in still water, so I'm going to let x be the rate in still water. So instead of that boat going up the Chena, if it's going up the boundary waters lakes that don't have any currents. So the current is 4 miles per hour, so as you go downstream, that adds to your speed. So your speed down is x plus 4. How about your speed upstream?
Subtract 1.
X subtract 4. This really matters for, like, fuel economy. Or like if you're, say, taking a boat and going up or down the stream, you're going to use more fuel going upstream. Or airplanes, right? They have to fly against air currents, don't they? Mm-hmm. Okay. So, and the other thing we know is that the time up minus the time down, as in the difference between them, is what? 1.6. This one's a lot to put together. And so because we have things that involve time, I have to solve this equation for time. Does that make sense? So if distance is rate times time, well then time is equal to distance divided by rate. Does that make sense? Okay. So in that case, for going up, does it make sense that time is 36 over x plus 4? Because it does, and this is it was a long time ago that we read this, but it goes 36 miles, right? Both ways. Okay, so 36, did I do the wrong? That should be x minus 4. Yes, I did. I'm so sorry. Yes, this should be x minus 4. Going upstream is going against the current, yep. How about the time for down, what's that? 36 divided by x plus 4. And that equals 1.6. Once, with all problems that involve stories, the hardest part is getting the whole equation in the first place, right? Once you've got that, it's not so bad. It's a little bad, but it's not so bad. So once you've got that equation, what do we do?
I want to turn 1.3 into an improper fraction.
You want to turn 1.6 into an improper fraction? Sure. You could make it into like 16 over 10. But anyhow, let's not do that. Let's just get a common denominator. How's that sound? Let's multiply the first fraction by x plus 4 over x plus 4. How about the second one?
X can't equal 4.
Yep. And the last one on the right gets multiplied by both of them, right? X plus 4, x minus 4 over x plus 4, x minus 4. I think I technically still have a minute. So that gives you 36 times x plus 4 minus 36 times x minus 4 equals 1.6 x plus 4 x minus 4. So everyone okay with that part of it? Okay. So 36x plus 144 minus 36x plus 144. Is everyone okay with that? You got 288 on the left equals 1.6. It's easiest this one to multiply those x's together first. As that difference of squares, they cancel. You get x squared minus 16. Minus 25.6. With a calculator, could you guys get it from there? You add the 25.6 and you end up with 313.6 equals 1.6x squared. What do you do next? And you end up with 196 equals x squared, and then x will equal 14.
Oh, okay.
And is that the speed in the, is that the, that's the rate in Stillwater, that's what they wanted, so 14 miles per hour. So we'll finish this one next time. Don't forget to work on Alex. For this one, we have two boats that travel at right angles to each other after leaving a dock at the same time. 1 hour later, they are 25 miles apart. If one boat travels 5 miles per hour faster than the other, what is the rate of each? So, if these boats travel from your dock at right angles, what kind of shape is this going to make? A triangle, yeah. So you've got boat 1 goes that way, and boat 2 goes that way. It doesn't really matter which way you draw your triangle, but the point is that they go in opposite directions. And yep, okay, I did fix it 1 hour later. Okay. Okay, so 1 hour later, they are 25 miles apart. Now, whenever you are talking about distance in math, the distance between 2 points is a straight line, right? Okay, unless you're on a sphere, in which case it's actually a bit more complicated, but we're assuming we have like a flat plane. So after an hour, this distance is 25. And again, you have rates and times, so you have this distance equals rate times time formula. How much time did it take for them to be 25 miles apart?
An hour.
An hour. Okay, so we're going to let r equal the rate of the slow boat. So if slow boat was going 15 miles per hour, slow boat's gone 15. Does it make sense then that this side of the triangle is r? Specifically, the distance traveled by slow boat is its rate times 1 hour. Okay, does that make sense? How fast is, if the slow boat is going R, how fast is the fast boat going?
R plus 5.
Mm-hmm. So R plus 5 equals rate of a fast boat. And so what's the distance on that other part of the triangle? It would equal R plus 5 times 1. Does that make sense? So its rate is R plus 5. So just R plus 5. What if I would have said 2 hours later and it was 25? What would be different there?
Divided by 2.
Would you be divided by 2? So if this had said 2 hours instead of 1 hour, your distance would be your rate times what goes in for time instead? 2. Okay, so just be aware of that. It was 1 because it was 1 hour. And now, what could you possibly use to get at those R's? It's a right triangle, isn't it?
A squared plus b squared equals c squared.
Exactly, the Pythagorean theorem. So you'd have R squared plus the quantity R plus 5 squared equals 25 squared. Okay, so that's R squared plus, well, this is R plus 5 times R plus 5, right? Is it R squared plus 25? No, what is it?
It's R squared plus 10R plus 25.
Great. Equals 25 squared, I don't expect you to know, but it's 625. Lots of experience, I happen to have that memorized. Okay, I'm not actually that good at doing multiplication in my head that fast. Or we can pretend that I am. I am that good at multiplication in my head. I think I'm super awesome. Okay, so we got 2R squared plus 10R. If you take away 625 from 25, I think you get minus 600. Does that seem right? And my original question, I had 2 hours in there, and then it didn't work out nicely, and I was like, how did the book get super nice answers? And realized the typo was I was supposed to be 1 hour for this particular question. Now, do you have to use the fancy factoring or quadratic formula? And if you did, could you make it simpler first?
Just root. Or you can
I was thinking divide by 2, right? Because that makes the number smaller, doesn't it? Even if you have to use the quadratic formula, at least you have littler numbers to work with. R squared plus 5R minus 300 equals 0. And that actually factored. It factors into R minus 15 and R plus 20. If you couldn't figure out how that factored, you could just use the quadratic formula. It will work. You know, it's just going to take a little bit longer. Keep very careful track of your zeros. So what are your two answers?
15.
Almost. 15 and the other answer technically from the equation is negative 20, right?
Yeah.
Does that answer in this context make any sense?
No.
No. So that one's an extra answer. So the slow boat has an O, is 15 miles per hour. How about the fast boat?
20. Just have to add 5.
Yep, exactly. Just have to add 5. I am 95% certain that it is coincidence that this 20 ended up being the opposite of that number. I don't think that always happens. Does that make sense? Okay. But the main point of this question is that, you know, for all these word problems, I think drawing a picture of what's happening kind of helps you get a feel for what needs to go where. And then lots of stuff comes from this whole distance equals rate times time formula. And you often don't know the rate and you know the time, or you know the time, don't know the time, know the rate. So you know one but not the other. Okay, one more. So one other thing you'll attack in calculus is some stuff about economics. So in some very simple cases, there is an optimal place to set the price so you make the most amount of money. Does that make sense as an idea? You set the price too low, you sell a lot of things, but you're not making very much per item, right? If you set it too high, you make more per item, but you sell fewer things, right? So it's like, how do you find that sweet spot where you sell just the right amount, like the Goldilocks spot, where you make the most money? And you use calculus to figure that out. And so a lot of it involves stuff like equations like this. We're going to use this equation to do something different. So this is a price demand equation for whole milk in a chain of supermarkets. So P is the price per gallon. Q is the number of gallons sold. Find the prices that will produce a revenue of $9,500. So why do you think they use Q? What word are they thinking for that? Quantity.
Which is not given, so how are we supposed to find this?
Ah, okay, which is not given, so how are we supposed to find this? Okay, so first of all, revenue, as an idea, revenue is equal to price times how many sold, right? Does that make sense as an idea?
Yeah.
Okay, so the price is a variable. You don't know what you're going to set it at yet, right? So our price is P. How many sold is that Q equation, isn't it? So revenue is price times quantity. Or it's P times 5600 minus 800P. Or, distributing your P, it's 5,600P minus 800P squared. And you want to figure out, when does this equal 9,500? So the equation you're solving is 9,500 equals 5,600P minus 800P squared. Does that make sense where that came from? Okay, and the whole idea being that revenue is price times how many sold. Okay, so let's put everything on the left side. So 800P squared will be positive, minus 5,600P plus 9,500 equals 0. Factoring probably isn't going to work for most real life problems because, factoring means you got like a super nice answer, and real life doesn't always work out that way. So you probably have to use the quadratic formula, but you're less likely to make errors if you use smaller numbers. So what could you divide this by to make the equation a lot simpler? Yeah, divide by 100, or, knock off 2 zeros from every term, right? Dividing by 8, I think, is going to make fractions. Does that make sense? I don't think it's going to go into everything evenly. Like specifically, the last term will be 95. Does that make sense? But you're right that if you could divide by 8, that would be the best thing to do. Because it does go into 56, doesn't it?
Yeah, that's the first one I thought.
Yeah, no, it makes total sense. But because that stupid 95, dividing by 8 won't work. I mean, it would work, but it's just going to be a fraction, and that's going to be more complicated. Okay, so just tell me what you get when you plug it into it'd be not x equals, it would be p equals. Does that make sense? Because my variable is p.
Everyone loves that.
Well, everybody always uses x because, x marks the spot. Okay, no one's going to laugh at my jokes. Okay, fine. All right, so negative b will be positive 56.
How did you get positive 8 p squared?
Oh, I took the stuff that's on this side of the equation
Oh, you moved to the other.
and went to the other side.
I moved it that way.
So in that case, everything that you have should be opposite. Like what you should have would be 0 equals negative 800p squared plus 5600p minus 9500.
Yeah.
Is that what you have?
Yeah, so do I need to make it the other?
Nope, you don't. Your numbers will work in the quadratic formula as long as you keep track of your signs in the proper way. I would still get rid of the zeros, of course. So plus or minus square root. So what comes next? B squared. So can I just say 56 squared?
Yes.
Minus 4 times,
8 times 95.
all over 16. Great. Okay, somebody with a calculator, could you pretty please work out the stuff under the square root sign?
3136 minus 3040.
So you had, say it again?
3,136.
Uh-huh, minus.
3,040.
Okay, what does that work out to be once you subtract them?
97.
96, did you guys get that too? Okay, over 16. Okay, and then what does 96 root to approximately? I got 9.79, is that what you guys got? Okay,
406.
so if a problem asks you to round to like 2 decimal places in the answer, you probably should not round to 2 decimal places right away. Does that make sense? The second that you round, you introduce some inaccuracy in your problem, right? So it probably is wise to keep like a lot of decimals in the middle and then round them at the end. And when we get to, we're gonna study like exponential growth. When you talk about like money and compounding interest, it's amazing, but if you round stuff differently, you can get vastly different amounts of money. It's kind of like if you guys see the movie, what is the funny one, The Office Space? Where the guys like scheme and they steal pennies from people. It's an old movie. Okay, never mind, we're done, show my age. Okay, so now the first thing you would do is you'd add 56 and 9.7 stuff and divide by, then after you get the sum, divide by 16. You get 411 and 289. So those two prices will produce a revenue of 9,000, and they both make sense, right? Like, you know, one of them, the only time when one wouldn't make sense is when one of them would be negative. And what you can think about is that this revenue, this one that has a higher price, that means they're selling fewer things of milk, right? Whereas this one, they're selling more, right? So maybe they're gonna choose to sell them for $4.11 and sell fewer and take the leftover milk and they're gonna like, you know, sell it to the yogurt makers so they can make more money. And one more thing, Alex does like give you a calculator when you're supposed to like do calculator problems. That calculator doesn't always do stuff. It's hard to make it do PEMDAS the right way. Does that make sense? So feel free to use your own calculators on those things. iPhones also suck at PEMDAS, so like, you know, you can try, but it's terrible. Okay.